Okay, so today we're going to start talking about how to convert fractions to decimals. Last time we looked at how to go from a decimal to a fraction. So tonight we're going to talk about how to change a fraction to a decimal. There's two methods that we're going to use. So let's get started. I'm going to start with an easier method. It's more direct, but the only problem with it is it does not work all the time. And you'll see in a second. Our book covers it as the second method. And then the first method that the book goes over, well, I'm going to do that second. So let's get started with this and see how we do. To start, what I'd like to do is kind of go over a little bit of vocabulary with you. Put that right in front. And we've talked about terminating decimals last week. That was our word of the week. Terminating decimals are pretty straightforward. They're decimals that terminate, they're decimals that stop. So if you look at the image on the screen, this is right from our book. A repeating decimal repeats a pattern of one or more digits. So when we do either of these two methods, actually when we do the second method that I show you, we could encounter some repeating decimals. So I'll bring that back up in a second. But then terminating decimals are decimals that we've worked with. They end, they stop, and they can be written as a fraction where the denominator is one of those powers of 10. 10, 100, 1,000, 10,000. So there were those decimals that we were working with when we were changing them to fractions, because all our denominators were tenths, hundredths, thousandths, and so on, where a repeating decimal cannot be written as a fraction where the denominator is 10, 100, 1,000. So let's move this out of the way. Okay, and let's talk about the first method for changing a fraction to a decimal. And again, I call it our first method. The book calls it the second method. Let's see. And this is it. Okay, so it says right there, key idea, method 2. I'm calling it our first method. This is writing fractions as decimal. To write a fraction as a decimal, write an equivalent fraction, if possible, whose denominator is 10, 100, 1,000, and you could do 10,000s, 100,000s. Not sure how many of us know, can work with fractions where those denominators would be that big. So if we look at the example, it says write 3/20ths as a decimal. And we recognize that 20 is a factor of 100, so we can write it as a fraction out of 100. 3/20ths equals 3/20ths, and we multiply the numerator and denominator by 5, and we get 3 times 5 is 15, 20 times 5 is 100, so 15 hundredths. And if we write it as a decimal as we read it, 0.15, 15 hundredths. Okay. So now what I want you to do, we're going to do a couple more, and I want you to do these with me. I'll do one, and then I'll have you do two on your own, and then we'll check our work together. Okay, so I'm going to get this out of the way. And here's our examples for on our own. Okay, so we have 4/5, slide it right up there, 11/20ths, and 7/50ths. Okay, so here I am again. Let's see, 4/5. So I write the fraction 4/5, and I recognize that 5 is a factor of 10. So I can write this as a fraction out of 10. And equivalent fractions, you multiply the numerator and denominator by the same number. So 5 times 2 is 10, therefore 4 times 2 is 8. And we have 8/10ths. 8/10ths as a decimal, 0.0, sorry, write 8/10ths as a decimal first, or identify your tenths place, which is the first place value, and the 8 goes into that place value. So there's our 8/10ths. So we can say that 4/5 as a fraction is equal to 8/10ths as a decimal. Okay, kind of covering it up there. There it is. Okay, so what I want you to do now is take a minute and see if you can't do the other two on your own. Okay, the 11/20ths and 7/50ths. So take 1 second, pause the video for me, because I can't pause it, and see if you can't do those two on your own. Okay, so we want 11/20ths, and what that would equal is a decimal, and 7/50ths, and what that would equal as a decimal. So pause now, and then when you come back, we'll go over it. Alright, so 11/20ths. If we see that, we should automatically know right away that 20 is a factor of 100. And since we're looking for denominators of 10, 100, 1000, our denominator here would be 100. And then 20 times what equals 100? 20 times 5. And 11 times 5 is 55. So we get 55 hundredths. And as a decimal, identify your place values. Tenths, hundredths. How many hundredths? 55 hundredths. Okay. And the next one, 7/50ths. Again, 50 is a factor of 100. 50 times what? 50 times 2. So multiply the numerator times 2, and I get 14. And 14 hundredths. Tenths, hundredths. That's 14 hundredths. Okay, so that's how we go from a fraction to a decimal. Pretty straightforward. But the only problem comes in, what happens when we have a fraction such as 2/3? There's nothing I can multiply by 3, no whole number that I can multiply by 3 to get a denominator of 100, 1000, 10,000, anything like that. So we need an alternative method. So this method, as it may look easy, this first method that I covered may look easy, it still leaves a little bit. It doesn't work all the times. So the next method I'm going to show you works all the time, every time. Okay, so first notice I have vertical lines. You're going to see why I have vertical lines in a second. Okay, so this next method, let's see, that's the one. Key idea, writing fractions as decimal. To write a fraction as a decimal, divide the numerator by the denominator. If you look at these two methods, alright, so 1/8 as a decimal, it's 1 divided by 8. Just as when we did numerator, and divided by denominator, trying to change an improper fraction to a mixed number, just as when we wrote the expression. Remember, 1/8 is an expression for 1 divided by 8. Okay, so first thing you do, as they have here, you bring your decimal point up to the line, add some zeros on the end, just like the book. I always add 3 zeros. And then you're going to divide as if they were whole numbers, because once your decimal point is in place up here, you're good to go. So you do the division, and you can see that in the numerator, or in the quotient, you have 0.125. So 1/8 is the same as 1 divided by 8, or 0.125. And then 5/6 is your other one. Notice 0.125 terminates, it ends. And then over here, 5/6 as a decimal, so that's 5 divided by 6. Put your decimal point in, bring it up to the line, add some zeros on, and divide as if they were whole numbers. 6 goes into 5, 0 times. 6 goes into 50, 8 times. 8 times 6, 48. Subtract, I get 2, bring down a 0, 6 goes into 20, 3 times. 3 times 6 is 18. Subtract, I get 2, bring down a 0. 6 goes into 23 times, times 2, times 6 is 18. Subtract, I get 2. And if you notice, the remainder keeps on coming down as 2. So this pattern isn't going to stop. This decimal keeps repeating. So we have 5/6 equals 5 divided by 6, or 0.833, or better written as 0.83. And if you look right there, there's a little bar over the 3. This is called bar notation. We're going to put the bar over the part of the decimal that repeats. Okay? Alright, now take a second, pause, you take a look at what I talked about, and I'm going to come back to you. Alright, let's get rid of this. And now, let's do some examples. So let's do one that works either way. So we had the one that was 4/5. And we did the example, or one similar to it. And we know that 5 is a factor of 10, 5 times 2 is 10, 4 times 2 is 8, 8 tenths, so it's 0.8. So we know what we're going to get already. But let's do it through the division. First of all, notice I have the vertical lines. So I want you to use these vertical lines as you do it. And here's why. So it helps you keep everything organized. So I set up my little fraction house. 4 goes on the inside, 5 is on the outside. Put my decimal point in, and out of habit, out of practice, out of whatever you want to say, I always put 3 zeros. I already know I'm not going to need all 3 of them. Okay, and we can put these here because we know that doesn't change the value. Once you put your decimal point in, you can put as many zeros in after that decimal point as you want, and you're not going to change the value of the number. Okay, my decimal point up there on the line, kind of an ugly decimal point. There, that one was better. Get that cursor out of the way. And we're going to start dividing. Will 5 go into 4? Nope. Once my decimal's on that line, though, we're good to go. I don't have to worry about the decimal point anymore. It's already taken care of. Will 5 go into 40? Yes, 8 times. 8 times 5 is 40. Subtract. I get 0. And voila, I'm done because there's nothing here. My remainder is 0. I'm done dividing. So I get 4/5, as we said before, is the same as 0.8 or 8 tenths. Okay? Let's try another one where it works nicely, where it's a terminating decimal. Let's try 3/8. I know the system terminates. Alright, so set up our division. 3 goes on the inside, 8 goes on the outside. Decimal point in, 0, 0, 0. I always add 3 zeros, it's out of habit. I may or may not need them. If I don't need them, that's fine. I don't need them. Alright, will 8 go into 3? No, it does not. 0 times. Does 8 go into 30? Once I have my decimal point up here, I treat it as if it's a whole number. So 8 goes into 30. 3 times 8 is 24. Subtract, I get 6. I bring down my 0. 8 goes into 60. 7 times 56. Subtract, I get a 4. I bring down my 0. 8 goes into 40. 5 times 8 is 40. Subtract, I get 0. I'm done. My 0 stops. My remainder is 0. I'm done. My decimal terminated. So what we can say is 3/8 is the same as 375 thousandths. Not bad. Okay. Now I'm going to show you some that don't terminate, that will repeat. Okay, but before I do, I want to take 1 second, 1 minute, to talk to you about repeating decimals. So there's that. Terminating decimals, repeating decimals. Repeating decimals, when we write them, we use something that's called bar notation. This decimal is going to go on forever. We're just going to write it as 0.3, and you put a bar over the part of the decimal that repeats. Okay, you might have a decimal like this. 5, 6, 5, 6, 5, 6. and it's going to go on forever repeating. So again, the bar notation for this would be 0.56 with the bar over the 5 and 6. This one up here, we'd read that as 0.3 repeating. This one right here, we'd read it as 0.56 repeating. And I'll give you one other one. Let's say it's 0.6727272. We would write it as 0.672 with the bar only going over the 72 because that's the part that repeats. And we read this as 0.672 with the 72 repeating. Okay? So the bar notation only goes over the part of the decimal that repeats. Back to this one over here for a second. This is okay. This means the same thing. This means the same thing. Okay? It's nicer, it's neater to leave it as that, but any of those variations work. Alright, so that's it on repeating decimals. Now I want to talk the rest of the time about dividing to convert a fraction to a decimal and show you a couple examples where they don't terminate. For example, 2/3. 2 divided by 3. So 2 goes on the inside, 3 goes on the outside, decimal point 0, 0, 0. Bring my decimal point up to the line. And say 3 goes into 2? No. 3 goes into 20? 6 times. 18, I subtract 2. Down to 0, 3 goes into 20, 6 times. 18, I subtract, I get it, 2. And right now I see that my pattern's going to repeat. I'm going to say 3 goes into 20, 6 times, 18, subtract. So this pattern is going to keep on going. First off, don't assume it's going to repeat. And second of all, keep dividing until you're absolutely sure it repeats. You might find out that it terminates after 3 or 4 times you do the division. So don't just automatically assume that once you get up to 3 decimal places or 4 decimal places that the fraction is going to repeat. You can't call it a repeating decimal until you're absolutely sure that it's going to repeat. So 2/3 is the same as 0.6 repeating. Okay? Alright, take over that. Let's try another one. Let's try 5/11. Okay. 5 on the inside. 0, 0, 0. Oops, didn't mean to do that. 0. I'm going to put another one on there and you'll see why. And you can always add more zeros. If you get to here dividing, or over here dividing, and you realize you need another 0, add another one on. It doesn't change the value. Alright, then we're dividing by 11. 11 goes into 5. Oh, don't forget, bring your decimal point up to the line. 11 goes into 5, no. 11 goes into 50, 4 times. 4 times 11, 44. Subtract. It's 6, bring down the 0. 11 goes into 60, 5 times. 5 times 11, 55. Subtract. I get 60 minus 5, 55, I get 4, I get 5. Bring down a 0. I can't make any assumptions yet. 11 goes to 50, 4 times, 44. Don't stop too soon. Keep going with the division. We haven't established the pattern yet. You may think you know it, and this is where people make the mistake. They stop here, and they say, oh, that's 0.454 repeating. Don't forget, the bar goes over the part that repeats. Okay? Or they do this, And then that's wrong, because that is 0.454454, and that's not what's repeating. Get rid of that. Get rid of all of it. We're not done yet. You can't do that until you establish the pattern for sure. 11 goes to 60 5 times, 55. Now we see that we've been down this road before. I get another 50 because we have the 50 here, here, and again here, and then we have this 60 here and here, and then we'd have it in the next time that we divide. So now we've established the pattern. So we can say that 5/11 equals 0.45 with the 4/5 repeating. Okay? All right. What's that? Oh, those ones we did. There's a couple for you. And again, I've told you that this method, the division method, works all the time. So take a second, try the 3/5 and the 1/9 and see what you get, and come on back. So I'll leave those there for a second. So there we go. So I get 3/5 and 1/9. All right, so take a second, see what you get. Okay, so let's do the 3/5. It's 3 divided by 5. 5 decimal point on, add some zeros. Again, it's my habit. I always do 3. You can do 1 and add them as you need them. I like to have at least 3 there ready to go. Alright, so 5 goes into 3, 0 times. 5 goes into 30, 6 times. 6 times 5 is 30. Subtract. I get my 0 here. I'm done already. So 3/5 is the same as 0.6 or 6/10. 1/9. 1 divided by 9. Put my decimal point in, add my 3 zeros. Bring my decimal point up to the line. 9 goes into 1. No. 9 goes into 10. Once. 1 times 9 is 9. Subtract. I get a 1. Bring down the 0. 9 goes into 10. 1. Multiply. 9. Subtract. I get a 1. 9 goes into 10 once. I see my pattern developing. My remainder continues to be 1. So I've established the pattern here. This is a repeating decimal. That 1/9 is the same as 0.1 repeating. Again, the bar only goes over the part of the decimal that repeats. Okay? That's all I have on changing fractions to decimals using division. The key to remember is that this method works some of the times. This method only works when your denominators are factors of 10, 100, 1000, 10,000. This division method works all the time. So if I had a choice to tell you which one to use, this would be the one. I would have you use division because I know it works all the time. There's no guesswork. Oh, is this denominator a factor of 10, 100, 1000? Doesn't matter. This works all the time. As we saw, 3/8, it's a terminating decimal. It worked. Okay? So, that's what I got. I'll see you tomorrow in class. Have a good night.